In our previous video, we learned how to find the slope. We learned that we could find the slope by dividing the change in the vertical distance. We call it vertical change. We call it vertical change. And then we divided the vertical change with the horizontal change. Horizontal change. That's what we did in the last video. And here we have something that looks like a slope. Yeah, it's like a slope. And you can see we have this is the slope, this is the height. Now we can say that this is the vertical. This is the vertical and this is the horizontal. And now this is the slope. Now, as you can see in our graphs, we have our vertical is, in our graph you can see that our vertical is here is 6 and our horizontal here is 9. So to find the slope of this line AB, the say here slope, the slope of line AB, the slope of line AB in our graph, that the slope of line AB is vertical change over horizontal change. So as you can see there, our vertical change is 6 and the horizontal change is 9. So the slope is 6 over 9, which is, if we simplify by dividing by 3, we'll get 2 over 3. That's the slope. But here's the trick. Where did they get 6 and 9? How can you get 6 and 9? Or where did these 6 and 9 appear in this graph? We are going to find the vertical change and the horizontal change. The vertical change and the horizontal change. Now remember, we said that the slope is the same as the gradient. Now when we are dealing with this graph, you are mainly going to call it the gradient. The gradient is the same as the slope. But now, how do we find the vertical change? How do we find the horizontal change? This is how we find the vertical change. The vertical change. Now, for our vertical change, we are going to find the coordinates of y. Yeah, we know that y is in the vertical, like here. This is y in the Cartesian plane. You learn about the Cartesian plane in grade 8, and I know you remember it. So this is the x. This is the x-axis, and that's the y-axis. Now, the y is where we have the vertical change. That's why we got our 6. Now, to find the vertical change, we are going to subtract the coordinates of y. Now, you see here there's a b. There's a b. Let's find the coordinates of b. For x, we have 7. And for y here, we have 9. So the coordinates of b are 7, 9, 7 for x axis and 9 for y axis. And what about the coordinates for a? The coordinates for a, you can see we always start with the x. So this is -2, and then when you go to y, you'll find that here is 3. You have a comma, then 3. So the coordinates of A are -2 and 3. Now, how do we find the vertical change? To find the vertical change, we subtract the change in y's. So the change in y's, the change in y in this case is 9 minus 3. 9 minus 3. And to find the horizontal change, you'll subtract the change in x. The change in x in this case is 7 minus 2. When you minus, you get a plus. So that's why you got 7 plus 2, which give us 9. You can see 9 minus 3 is 6. Now you can see where we got these vertical and horizontal changes. You can see here, this 6 and this 6 here. This is the vertical change. And this 9 here, you can see it here. That is horizontal change. So what have we discovered? What have we learned? What have we learned? Let me reduce that one. We have learned that to find the horizontal and the vertical changes, we have to subtract the axis. Now, this is a lesson. This is the takeaway. This is what you have learned. To find the vertical change, to find the vertical change, we subtract y1. No, we subtract y2 minus y1. Yeah, y2 minus y1. We have seen that we have subtracted 9 minus 3 and we got 6, which is our vertical change. Now to find the horizontal change, to find the horizontal change, we subtract x2 minus x1. And we've seen this graph that when we subtract our x2, which is 7, minus our x1 is -2 minus -2, we get 7. And then when you subtract minus and minus, when you open this bracket, you'll get a plus. So we got 9. This 9 is what we have on the horizontal change in this graph. So how do we find our gradient? We find the gradient by vertical change divided by horizontal change. So we can say that the gradient is vertical change. Let's write it here again. The gradient is the same as the slope, but in maths we are going to represent it by letter m, the small m. So our gradient is going to be change on the vertical side over change on the horizontal side. Now, we say that in maths you don't need to write so much things. You don't need to write so much things. So we are going to represent change by delta. This is the delta. Whenever you want to write change, you can just write the delta. Now, here we are going to represent the change by the delta. So vertical change is going to be change in y. Yeah, and the change in y, as we have discovered, the change in y is y2 minus y1. Then we have here division, change in x. And what have we found the change in x? For the change in x, we subtract x1 from x2. x2 minus x1. So this is what will be using this formula is what you'll be using to find the gradients of straight lines. The gradient of straight line is just the same as the slope is the vertical change over horizontal change, and that is change in y over change in x. That is y2 minus y1 over x2 minus x1. Yes, this is your dear formula for now. With that illustration, it's very, very important that you remind yourself, you recap how you plot points on Cartesian plane and how you locate points on the Cartesian plane. So here, if I ask you to find the gradient of A and B, if I ask you to find the gradient of A, B, you'll have to locate these points so that you know what you'll be subtracting. The y-intercept, subtracting the y-intercepts, and then dividing by the x-intercept. So let's find A. You start by finding the coordinates of A. How do you find the coordinates of A? We're just reminding ourselves. I know we know this. So for the coordinates of A, we always start by x and then y. You can see here A. This is our x and this is our y. So the coordinates of A is going to be, we start by x, you write here -2, and then you write a comma, and then you write 1. So the coordinates of A is -2, 1. We can specify it here, -2, and then 1. And then what are the coordinates of B? The coordinates of B will use the same method. Here, we are always starting by what? By x. So our x here is 4, and then we go to our y, which is 5. So the coordinates of B will be 4. We start by x axis 4, and then we have 5 here. So let's transfer it. 4 and 5. Now with this, you can now comfortably calculate your gradient because you have the two known points. Now what are you going to find when just a reminder, when you're finding the gradient is the same as the slope, and you know the change in y and the change in x. Now this is the change in x here, this is the change in x, and this is the change in y. So what we are going to find is the distance. You are going to find the change in y. This is the distance here, which is the change in y, and then we are going to divide it by the distance here, which is the change in x. So let's do it. I say that you are going to use letter M, small m. How do you write the small m? You're going to read small m, the small m, to represent the gradient. And then in maths, because we are so lazy, you don't want to write the change in wherever change. So we are going to use the delta to represent the change. So we are going to say this change in y, or the change in x. Now, what is the change in y? You are going to subtract y2 minus y1 over x2 minus x1. Now what are those figures? Y2, that is 5 minus 1. This is 5 minus 1 all over 4 minus -2. So our answer is going to be 4 over, when you open brackets of a negative and negative, you get positive, so it's going to be 4 plus 2, which is 6. And if you simplify 2 there, is 2, and 2 here is 3. So it's just simple like that. If you have the two known points, you just get the x and y coordinates. You subtract the y coordinates and you divide by the x coordinate, and you get your gradient. Now let us test ourselves with this simple one. Find the gradient of the line passing through the points 2, 3, and 5, 9. So for the gradients, we know that our change in y over our change in x. Now let's find the change in y. The change in y, we have 9 minus 3, and 9 minus 3 and 5 minus 2, 5 minus 2, and this gives us 9 minus 3 is 6, and 5 minus 2 is 3, and if you simplify, you get here 1, 1, and your gradient is 2, and let's mark the answer as 2. Let's go to the next one. What's the gradient of a line that passes through 1, 10, and 4, 1? The formula for gradient is very simple. For gradient m, to find the gradient, we have to find the vertical change, which is y2 minus y1 over the horizontal change, which is x2 minus x1. Now y2 would be 1, and then minus 10, and then our x2 is 4 minus 1. Now 1 minus 10 is negative 9, and then 4 minus 1 is 3, and if you simplify further, we divide by 3. 1 we divide by 3 here, you get 3. So our answer is negative 3. That's of it here, negative 3. And for the last one, a straight line is plotted on a coordinate plane. By observing the grid, you identify that the line passes exactly through point A and B. What's the gradient of this line? So for us to find the gradient of the line, we must have those 2 points. We must have the coordinates of those 2 points. So let's find the coordinates of those 2 points. You did this in your grade 8. And just for a recap, how do you find coordinates? Let's find the coordinates. So let's start by finding the coordinates of A. This A here, and you remember coordinates must be x, y, xy in the form of xy. So here for A, we are going to start by the x. Here the x is negative 2, and the y is here negative 5. So A, we're going to start by the x, which is negative 2, and then a comma, and our negative 5. Negative 2 and negative 5. That's right, so negative 2. Well, negative 2 and negative 5. Those are the coordinates. And then for B, we're going to start by the x, and you can see here the x for B is here, which is 2, and then for y here, which is 3. So for B, we are going to have 2, 2, 3, and let's unclose it. Let's unclose that one. Oh, 3, 2, 3. Now we have our coordinates here. Let's obtain our coordinate, transfer them. We have for point A. For point A, we have negative 2 and negative 5. And for point B, we have for point B, we have 2 and 3. 2 and 3. Now with these 4 points, now with these 2 points, so we have 4 coordinates, and now we can find the gradient. What we are finding is the change in y. The change in y would be here. Let me use this one. The change in y will be here, over the change in x. This is the change in x, and here we have the change in y. So we are going to subtract to find the change in y and the change in x. So our gradient term will be y2 minus y1 all over x2 minus x1. So this we are going to have is y2. What is y2? y2 we have negative 5. We have the negative 5 minus 3. Negative 5 minus 3. And for our x2 we have negative 2 minus 2. So what we get when minus, we get negative 5 minus negative 3 will give negative 8. And then down here we are going to have negative 4. Negative 2 minus negative 2, negative 4. And we simplify them. Negative 4 here 1, negative 4 here 2. So our answer is going to be 2. Our gradient is going to be 2. And now we can, that's how we do it.